Our next speaker, Roseanne Mcconnell, is yet again somebody else who's done a lot of really extraordinary, productive things. Enlisted in the Navy, again, I think three Navy vets out of 12 students in this room right now, enlisted out of high school, I believe, served and had a career in air traffic control, and also, I'd like to point out, was a weather forecaster at some point during her career. And she's worked as an air traffic controller, I believe, in the private sector and the military. And again, somebody who really likes to tackle challenging, important problems. And the whole theme of this section, Michael's project, Roseanne's project, Annika's project, is, this global national climate issue, but taking solutions and applying them at the local level. And I think Roseanne has found something really interesting here in terms of a model of connecting scientists with communities in a way where scientists can really operationalize both their skills and their attachment to their communities to effectuate positive change on issues related to climate. So really enjoyed having Roseanne in this program very much, and I'll miss her after she finishes. But for now, the floor is yours, Roseanne.
Thank you, Corey. My name is Roseanne Mcconnell, and my capstone is integration of local scientists into local communities to solve local problems. Communities, especially marginalized communities, face many challenges and problems. Politicians and most of the city officials don't really have the science background to clearly address many of the issues facing communities across the US. Climate change has rewritten the history books in climatology. According to the EPA, changes in weather patterns are associated with rising global average temperatures. These higher temperatures are impacting droughts, precipitation, storms, floods, and wildfires. So the question is, how does a community address any of these issues? And many of these communities face multiple issues simultaneously. As Corey said, my background was the Navy. I went to the recruiter and signed up to be a weather forecaster. That was my plan, with a little bit of oceanography maybe in my future, but I thought the Navy would be a good place to have that kind of career because everything they do is out in the ocean. Every naval base is near an ocean or a body of water. So come back, announced that to my parents, and my mother didn't say a thing. She was just in shock, and my father said, no, you're not. You're going to be an air traffic controller. And I opened my mouth, but nothing came out. But I did go back to the recruiter and said, I've got to change this. I've got to sign up as an air traffic controller. He says, what is that? I said, I have no idea. And he looked it up in the book, and that's where it goes. So that's what I did. There was a few reasons, but I always had a connection to the weather, always impacted by climate change. So there we go, air traffic control, because it was a marketable skill. I didn't even know what that meant, but that was my father's intention. If I'm going to go away to go away to the Navy for so many years, like it's a school, I'm going to come out and have some sort of skill. And that was his plan. So I did get out as soon as I could. I either loved it or hated it, had some good times, had some bad times, but I stayed in the military along the way. And being an air traffic controller, they retire you early. They, for many reasons, but they say, okay, you're done. So they say you're hanging up your headset and off you go. So I was like, what next? So here we have climate change and the 2016 election. And I think every day there was something new. First one was the plan to withdraw from the Paris Agreement. That struck me. The actual redrawing of a hurricane's path with a Sharpie, that got me. The decision to open the Arctic to offshore drilling, that really got me. Never been to the Arctic, probably will never go to the Arctic, but that impacted me, like that there was something wrong. So I wanted to be involved. So I made a direction change and was familiar with here, and this program has been a great fit for me. Again, the climate change headlines. Yes, the drought we face here in California, minimal amount of rain, 9 inches maybe in a year. Carbon dioxide, even during a pandemic, breaking records. Warming seas are accelerating Greenland glacier retreat. And 2020, we tied for the hottest year on record. And according to NOAA, the 2020 hurricane season was the most active Atlantic hurricane season on record, with 30 named storms, 13 of them are hurricanes. Additionally, according to NOAA, the U.S. in 2020 experienced a record-smashing 22 weather or climate disasters that each resulted in at least $1 billion in damage. $1 billion in damage. I just kept thinking these numbers are astronomical, and communities are getting crushed by this. So my motivation for my project was local scientists. A lot of local scientists, they remain in their labs, they do experiments, they crunch numbers, data, but they're doing research. They do a lot of research. But there's scientists, local scientists in every community. And there's local communities that have issues, that have local problems. So why not connect them and have the scientists be able to go in their own backyard. I mean, I know it's important to do research all around the world, but this is where we live. So the other key was, how do you get a scientist to volunteer? You're just asking them to come on board, community project, low level. So you just kind of give them, a chance to work in their own backyard, a sense of pride in their own community. To me, that sounded like a win-win. So I go back to that marketable word. I realized I had no environmental skills. I had no experience in anything environment. So I applied and got accepted to a community science fellow volunteer through the Thriving Earth Exchange, part of the AGU, American Geophysical Union, and they were partnering with the American Meteorological Society. So that was my plan, to get a community project. In the Thriving Earth Exchange model, they have four stages. First one would be scope, thorough understanding of the community and project. The second one would be match, finding a local scientist and an engineer. That's where the idea came from. Third step is solve, crafting a community agreement to address the problem. And then the fourth one would be share lessons learned and final report. So I was assigned the project at Sandy Springs, Georgia. It's, as it says, springs. It's surrounded by the Chattahoochee River on the western border, and it's got springs and rivers and lakes throughout the entire community. It's a fairly new city. It was incorporated in 2005, although they tried from the 70s to incorporate it, but they stayed as just part of the Atlanta. But it's Fulton County. Climate is humid, subtropical, hot and muggy. Average rainfall is about 53 inches a year. They've got a very engaged community and HOA. They get involved. There's a lot of groups that are actually in place, and they want to keep it as nice as can be. But our scope was implementation of green infrastructure to improve stream water quality and, if feasible, reduce flood risks in the Coalwood Creek watershed. So I'll show a picture. This is the Coalwood Creek watershed. Very, very small. They picked it because it was completely within the confines of the city, and they could implement all kinds of anything they needed to, because they didn't have to get any of the other counties that were bordering it, because as we know in a watershed, what happens upstream is going to end up downstream. So they couldn't really control that because that was another jurisdiction, but we could control what was in the Coalwood Creek watershed. So what is a watershed? Well, that's a picture. I haven't been there, but that's a picture that they sent me, and the back behind that tree is the Chattahoochee River. It's very nice, very green, but when it rains, that's a problem. And basically what a watershed is, it's a land that channels water into waterways. It includes reservoirs, bays, and filters into the ocean. Some of the water gets absorbed into the soil or aquifers. The size can be from a few hundred to hundreds or millions of miles. Ours is a few miles. The largest is the Mississippi watershed, and they go by HUCs, or hydrologic unit codes, based on their geography and the soil characteristics and the land cover. So this came from just last month. My community partners went out there and actually did an on-site visit, and they pointed out that it was in very good condition. They said that it wasn't really overrun. They sent me a whole bunch of pictures, and some of the streams are overroding, and that's what we're going to focus on. But 2009, they had a major flood, and the city actually applied for a buyout program by FEMA, and it's a whole big lengthy process, and they got accepted to it. And one homeowner, the pointer doesn't work, but you can see it right in the middle with the purple arrow. That was one homeowner that decided to sell their home. So now the city of Sandy Springs owns that property, and they could probably make it into a park, but they really can't develop it in any way. So green infrastructure. So we'll talk a little bit about green infrastructure. It's water mediation, restores, replicates. Again, planting trees and restores wetlands, restore floodplains. Everything is restoring back to its natural environment to make it do what it's meant to do. Reducing development. It's very cost effective if implemented right. Some say that for every dollar you put into green infrastructure, you get $6 back in return. Big part of green infrastructure is actually educating the public about water efficiency. A lot of people don't know much about the water efficiency. And it combines natural and environmental with engineered solutions. So then we moved on to the match phase and finding a scientist or engineer. So we put basically a scientist wanted ad, and was sent out on the AMS, Thriving Earth Exchange AGU website. I sent out emails, I made phone calls, and we got right in the neighboring town, part of the University of Georgia system, Kennesaw University. It's a professor of civil engineering. He had some experience in environmental management, joined our team. He brought hydrologists in that had experience, and actually they did do some modeling in Sandy Springs, and then they had additional support that had modeling experience, and we were on our way, so we had a match. And quickly, a little bit about hydrological and hydraulic modeling. This is going to be the hardest part of the project. It's very time consuming. So we asked for a 2-year water quality model and a 25-year water mitigation survey. We get that from GIS data. We need every pipe, every stream, every river, every puddle, pretty much anything that can be that holds water. We put it into a layer on a GIS map, and we bring it back, and then they start their modeling. And the modeling programs that we use is HECRAS, that does future flood risk water quality analysis, and that is Hydrologic Engineering Center's river analysis. The Army Corps of Engineers owns it, but they allow others to use the software. And then the other one is hydraulic, surface subsurface flows with SWIM. That's stormwater management model, and that's from the EPA. So we've talked a little bit in other talks, the American Jobs Plan. Yes, it's big, it's bold. We can get it done if we can get it passed, and that's the key. It's going to rebuild our country's infrastructure. It's the largest jobs program since World War II, and we're referring to it as this generation's New Deal. But again, it has to pass both houses of Congress. So making the integration, my plan of action. So Sandy Springs does have a master agreement with Kennesaw State University. That's where my scientists are from. So that would create a template for any other city and any other university or college. Focus on the lower income communities that have limited resources. Expand community involvement through churches, retirement, and civic groups. I think it's real important that, that people get involved, and they will once we get to that phase. So again, we'll have a sample template connecting a city with a college, target the lower income communities, target colleges with environmental courses, focusing on utilizing city as an urban-rural laboratory, potentially create a course that would last the entire semester, and stress that no financial impact is anticipated to either party. And with me, probably Thriving Earth Exchange is they do community projects throughout the year, and I would probably hope to continue working with them and sort of get my idea through to them, because I tried to find other communities that had agreements, and I really couldn't find any formal agreements. Informal agreements, something like Imperial Beach and SIO, Scripps, they work with flooding. Other communities have maybe a community college comes out and does one cleanup, or a cleanup a day, or and the community college helps them. Another one does a food bank, but nothing formal. So I would try to sort of see if this would work, and so it would be a win-win. And at that, I'd like to thank my Capstone Advisory Committee. They helped me along the way and kept me focused, and thank you again.
All right, thank you so much, Roseanne. Any questions from the room? Mark has his hand up.
Thank you, Rosanne. That was a great talk. I think your mention of Imperial Beach, I think that would be a great place to start. They're really eager, and there's a mayor there who's very science-oriented. And the other part that they really want to see more connection with Scripps is education. So creating projects that filter down into K through 12 and support particularly underserved populations and educational opportunities. So I think there's a partner here in the county who would be very interested in your project. It's just a comment more than a question.
That'd be great, because just me, little old Roseanne Mcconnell, making phone calls to cities, they either never answer my phone calls or emails. So having somebody behind me to say, this is a good idea, let's take a look at it, would really be a positive thing and a positive impact.
Any more questions? We're going to move a little more quickly now because we're a little short on time. Thank you so much for your presentation.